Hi guys, and welcome to my channel. This video is on trigonometric proofs. It's really done in advance, covered in Form 4 and sometimes in Form 5. So please stay tuned to see how I would break down three complex questions into a very simple and understandable way. Now, for us to even do a trigonometric proof, we first need to know some identities. Now, these identities here, these 1, 2, and 3, really just come from this first one, this one here, and it's manipulated to give us this one and this one. So all you need to learn is really one, and you can understand all the others. This other one here, it's very simple. Tan theta is equal to sine theta on cos theta. Now, once you've learned these, then we move on to the more complex ones. This one is called the compound angle formula. And this one down here, this section here is called the double angle formula, which is actually the same thing as above. It's just if it was A plus A. Now, I'm going to go through a few questions and show you how I use these three sections. This is my first section, my second section, and my third section to prove that the left-hand side is equal to the right-hand side. So now let me move on to my first example. So this is my first question. It says, prove that 1 on cos x plus 1 minus 1 on cos x minus 1 is equal to 2 on sine squared x. Now, the first thing we need to identify is this side here is the left-hand side, and this side on the right side of the equal sign in the middle here is the right-hand side, obviously. So what I usually tell my students is we need to choose one side, work on that one side, and see if we can get the opposite side. So say I choose my left-hand side, I'll work on the left-hand side and get the right-hand side. Or if I choose my right-hand side, work on that and get the left-hand side. Now, what side do we usually pick? Well, we pick the one that is more complicated. So in this particular example, I will pick my left-hand side, seeing that I have two fractions here. I could simply expand this by finding the LCM, get it to one fraction, and see if I get the right-hand side. So now I'll proceed to do that. So this is what I would usually write up. I'll say taking left-hand side and I'll go on. Now to find the LCM of this, it will simply be the multiple, as if I were to multiply the two, right? Now, cos x plus 1 into all of this would be cos x minus 1. Cos x minus 1 by 1 would be cos x minus 1. Now, cos x minus 1 into all of this would be cos x plus 1. That multiplied by 1 would be minus cos x plus 1. So now what I'll end up getting here is cos x alone minus 1, multiply by here, that minus 1, I'll get minus cos x minus 1 all over cos x, plus 1 and cos x minus 1. Now I don't know if you realize this, but this is actually difference of two squares. So the bottom here would actually be cos squared x minus 1. Now for the numerator, I have a cos x here and a minus cos x. So these two will cancel. Minus 1 and minus 1 will give me minus 2. Now looking back at my answer, I could see that I need to get a 2 on top and I need to get a sine squared x. Now I have a 2, but I have a minus 2. So what I need to do is I could take this minus and apply it to the bottom. So I'll end up getting 2 over minus cos squared x minus 1, which will end up being 2 over minus cos squared x plus 1, which is actually 2 over sine squared x, if I were to refer to this formula here. Right? So now I could see that I got my right-hand side, so then I could say, hence proven. So now this is my example 2. It says, prove that cos of a minus b over sine b cos a is equal to 1 over tan b plus tan a. Now, seeing that one side has cos and sine and the other side has tan, I may need to use this formula here, right? But we'll see about that eventually. Now, again, we will choose the more complicated side. To me, I will think I want to choose the left-hand side. So I'll say taking left-hand side, cos of a minus b over sine of b cos of a. The first thing I want to do is expand this numerator. Cos of a minus b is right over here. And it says this here, so I will write that out, cos of a, cos of b, plus sine of a, sine of b, all over sine b, cos a. Now, when you have something like this, where you have one denominator and you have more than one numerator, like here, I could separate this into two fractions. So I could put cos a, cos b, all over sine b, cos a, plus, since there's a plus sign here, sine A, sine B, all over sine B cos A. Now this is very nice. So now I can start to cancel cos A and cos A. Oh sorry, not this one. It'll be sine B and sine B. So what do I have here? Cos B, sine B. Nice. And sine A, cos A. Now this section here is actually tan A, which is what I want. I want to get a tan A. But this one here, cos B over sine B, well, will actually be 1 over tan theta would be cos theta over sine theta. So this actually, guys, would be 1 over tan B. So, everyone, hence proof 1. Now, let me move on to my third and final example. So in this question here, it says prove that 1 on sine 2a plus 1 on tan 2a is equal to 1 on tan. Now again, this side here looks like the more complicated side. So I'll say taking left hand side again, right? And here now sine 2a tan 2a, I would have to use these sets of formulae. Now there's a common a here, but of course this could mean anything. It could mean theta, we could change it to theta, capital A, etc. Same for here. This could change to theta, and so on, right? X and Y and so on. So now, if I were to simplify to the left-hand side, I'll get 1 on sine 2a, writing it back, that is 1 on tan 2a, will actually be 1 on sine 2a, and this tan, well, from here, is plus 1 on sine 2a over cos 2a, which is actually 1 on sine 2a plus 1 divided by sine 2a cos 2a, sorry, which is 1 on sine 2a plus 1 multiplied by cos 2a sine 2a. So that works out to be 1 on sine plus cos 2a sine 2a. Now the nice thing about here now is that I have a fraction here and a fraction here with the same denominator. So this is 1 plus cos 2a, if you write it all as 1, sine 2a, right? So now at this point now, I would want to do some sort of substitution because I need to reflect here and see that I have to get 1 on tan of a. So tan of a would mean down here has to be sine a cos a, right? So I need to work on that. So now, let me work on this here. So I could actually use cos 2a, one of the substitutions for cos 2a. So seeing that I will have a sine 2a at the bottom, I feel I should use a cos 2a substitution that has a sine only in it. So that would be probably this one, right? So at this point here, I will write 1 plus, instead of cos 2a, I'll put 1 minus 2 sine squared a all over sine 2a, right? But you know what? Let me substitute for sine 2a as well. Sine 2a is actually 2 sine a cos a. So I'll put that in one time, 2 sine a cos of a. So now simplifying the numerator here, I will get 1 plus 1 minus 2 sine squared a, and this will be 2 sine a cos a. Now the reason why I wanted to substitute for the sine 2a as well is because I need to get rid of this 2 in front of it, right? For me to only have sine a cos a and eventually be a tan a. So that is why I opted for substituting for this formula here, right? So now let me go ahead. My numerator now becomes 1 plus 1, 2 minus 2 sine squared a, nice, 2 sine a cos a. Now the top here I can factor out 2. Lovely. Now what can I do here now? You guessed it, cancel this and cancel this. However, 1 minus sine squared a is the same as this, cos squared a. So I could write cos squared a on top here for that, sine a cos a. So since this is cos squared a and this is only cos a, this will cancel here and this will take off one of these. So now I have, guys, cos a sine a, which is actually the reverse of tan a. So that's actually 1 on tan a. So everyone, this is the end of my third and final question. So with that said, I hope that you followed, I hope that you understand, and I hope that you are less intimidated by questions like this. Please feel free to share, like, and follow me. Thanks, guys.